In this video, we are going to be stating and proving the isosceles triangle theorem. So let's start by talking about what is the isosceles triangle theorem. Well, here is a statement of the theorem. It says, if two sides of a triangle are equal, so like this triangle, these two sides are equal, then the angles at the bases of these sides, these two angles, are also equal. And this comes from Euclid, and this is from Euclid Book 1, or Euclid's Elements, Book 1, Proposition 5. All right, is one of the first 5 propositions he proves in his booklet, or in his book. And it is one of the bases of triangle geometry. So all we're saying is that in an isosceles triangle, both the two of the sides are equal and the angles at their bases are equal. The word isosceles is telling us that the two sides are equal. So now we're going to prove that this is true because it is a relatively simple proof to do. So I'm going to do a bit of a paragraph proof here. So we're given triangle ABC, and AB is equal to AC, making this an isosceles triangle. What we need to prove is that angle B down here, this angle, is equal to angle C down here. And here's how we do that. So we're going to draw the bisector of angle BAC. So we're just going to take, and we're going to draw a line that takes this angle BAC, oh, that was bad, try that one more time, and cuts it directly in half. All right, so we're going to say that this side, or this segment here, if I can get it to be, there we go, that's better. So we're going to say that this segment here is the angle bisector of angle BAC. All right, we're going to name it AM, so we're going to say that this point here, call that M. Okay, well now, if it's an angle bisector, then this angle here, BAM, is equal to this angle here, CAM, because it's the angle bisector. Okay, well we also know the angle, or the segment AM is congruent, whoa, didn't want that to happen. The segment AM is congruent to itself by the reflexive property. Obviously, a side is equal to itself. Well, now what do we see? We have a side, an angle, and a side that are equal to a side, an angle, and a side. So we know, therefore, this triangle, BAM, this triangle BAM here, is congruent to this triangle CAM by side angle side congruence. Well, if these two triangles are congruent, then we know that all of the corresponding parts of those triangles are congruent. So we can say, well, angle B corresponds to angle C, and therefore they're equal to each other. And thus we've proven that in any triangle with two sides that are equal to each other, then their base angles must also be equal to each other. And this is what we call the isosceles triangle theorem. And that's all there is to it.